Greetings, Year 9 lovers of mathematics. It's time to do some more exciting work on probability and data. Today we're focusing mostly on data, but let's get into it. So the first of the two exercises we're going to cover this lesson involves measures of spread. Now, that's a fancy way of saying the range and the interquartile range, and let's discuss what that is. So first of all, the range is when you have a group of numbers and you take the biggest number in the group and the smallest number in the group and you subtract them. And technically we don't call them the biggest number, we call it the highest data value. That's a fancy way of saying the biggest number in the group minus the lowest data value, the smallest number in the group. The interquartile range is a little bit different. Here's an example. Let's say I have a group of numbers 2, 4, 8, 10, 12, 80, 90 and 92. There's some numbers. What we actually do when we have interquartile range is we actually chop off the first and the last quarter. So chop off the first 25% of the numbers, the last 25% of the numbers, and we find the range of the middle 50% of the numbers. That's what it actually means. We're finding the range or the spread of the middle of the numbers. So let's write that down officially. The interquartile range considers the middle 50% of your data, and we call Q1 the lower quartile, or Q1 as we'll call it in the formula. That's what we call, or sometimes it's called the first quartile, but it's the 1/4 way mark in our group of numbers, and we'll show you how you do that in a moment. The upper quartile, or quartile 3, is the 3/4 way, or the 75% mark in our group of numbers, and we'll do an example in a moment. But the formula to find the interquartile range is the 3/4 way mark number minus the 1/4 way mark number. So let's try some examples. First one says find the range with the given numbers. Well, first thing we need to do is find the smallest and the biggest number. So there's our smallest and our biggest number, so we minus them. So you just do 9.8, take 3.4, which is 6.4, and that is the range. Let's try our second example. Here we've got a group of numbers again. Now it's important that when you're wanting to do the interquartile range that we actually order the numbers from smallest to largest. So that's what part A asks us to do, to reorder the numbers from smallest to largest, because they're not in a particular order. So I've written them out there so we can see it. And what we need to do now is count how many numbers there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers in this group. And if we're going to find the range, we do the biggest number minus the smallest number. We didn't need to order it for that. But if we find the median, it must be ordered. Now we said there are 13 numbers. Now if there are 13 numbers, the way it could work is like this. If there are 13 numbers, I can split that into two groups of 6 numbers, and I'll have one little lonely number in the middle. So if I actually count in 1, 2, 3, 4, 5, 6, that's my lonely number in the middle, and let's just double check. 1, 2, 3, 4, 5, 6 numbers to the left of it. 1, 2, 3, 4, 5, 6 numbers to the right of it. So that number is my median, which is the middle number. So we can mark it. The median is 5. If I need to find the lower quartile, now that I've marked my median number, to find the lower quartile, I focus on all the numbers on the left side of my median. You don't include it. You would if you're in America, but we're not in America. So we look at those numbers in the red box, and we have to find the halfway mark of those numbers. So when you look at those numbers on the left and you're trying to find the halfway mark of those numbers, hopefully you could see it's between this and this. and they're both 3's. Halfway between 3 and 3 is 3. Now if they were different numbers, you could actually add them and divide by 2, and you'll get the missing number if it's a tricky one. But 3 is fairly obvious, so the lower quartile is 3. To get the upper quartile, we're going to do the same thing, but we're going to look at the numbers to the right of the median and find the halfway mark. Now the halfway mark, we can see we've got 3 digits, halfway is between 7 and 8, and halfway between 7 and 8 is 7.5. But if you weren't sure of that, you get on your calculator and you do 7 plus 8, and then you divide it by 2, and that'll give you 7.5. So the upper quartile is 7.5, which means the interquartile range is Q3 take Q1, 7.5 take 3, or 4.5. Remember, the interquartile range is, when you look at the middle 50% of the numbers, it's this number between 7 and 8 minus this number between 3 and 3, and it tells you that there's a 4.5 spread over the middle 50% of the numbers. Let's continue. Here we've got a whole lot of measurements about somebody who's been doing the long jump, and these are the different attempts. Probably would have been a little easier with some commas between them, but they're there. So we've first of all got to list the data from the smallest to the largest. So there are the numbers listed from smallest to largest, and you need to go through that process, and you can quickly copy it down if you like, or you can figure it out for yourself. But now let's focus on part B. It says find the range. Well, that's easy because that's just the biggest number take away the smallest number. 9.2 take 5.1 is 4.1. Let's try and find the median though, the middle number. Well, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is good because it says up here there are 10 long jump attempts. If you have a group of 10 numbers, that actually would split into 2 equal groups of 5, and there would be nothing in between. So what I need to do is go and find the point where I've got 5 numbers either side of my line here. And so I've got 5 numbers to the left and 5 numbers to the right. So the median is halfway between 8.2 and 8.3, which is 8.25. And if you weren't sure of that, you'd go 8.2 plus 8.3, push equals on your calculator, and then divide by 2. So our median is 8.25. The lower quartile, quartile 1, we now look to the left-hand side of my line. Where's the middle of those 5 numbers? So we can see it's that one there. So when we look to the left, we can see 7.1 is the median. Sorry, not the median, the lower quartile. Let's go to the right-hand side to find the upper quartile. The halfway number is 8.8. We can see that there's 5 numbers. The halfway number is the number 8.8. So that is the upper quartile, or Q3. And to find the interquartile range, it's Q3 take Q1, which is 8.8 take 7.1, or 1.7. So that's how our interquartile range works. Remember, it's really important to order the numbers from smallest to largest before you do anything else. Now, what does the middle quartile range mean? Remember, it's the range of the middle half of the data, or the middle 50% of the data. That's what it actually means. Now, the second exercise we want to look at is box plots. Now, box plots require you to know how to find the smallest and the biggest number, Q1 and Q3, as well as the median. So, we have 5 pieces of important information, and we call it a 5-point summary. You're going to need to know the lowest score, the lower quartile, the middle score, the upper quartile, and the highest score. And I didn't mention this in the previous exercise, but sometimes Q1 is called the first quartile, sometimes Q3 is called the third quartile, because it's got 1 and 3 there. Now, a box plot is where we actually plot all of these 5 pieces of information. Now, here's an example of a box plot. The most important thing you need to understand with a box plot is when you look at the scale, that the jump from 0 to 1 and 1 to 2 and 2 to 3 and 3 to 4 and so on is a consistent gap. Sometimes I see box plots that go like this, and this is very wrong. They'll go 1, 2, 3, 4, 5, and the spacing is all over the place. And that's very wrong. So don't do a box plot like that. And sometimes I see it like this. Oh, the number 1 is in the data. The number 2 is in the data. The next number's 5, and the next number's 7, and the next number's 11. It's not about what numbers are in the data. This is a number line. So all of the counting numbers need to be represented. So that's not the way to do it either. You need to make sure you have a number line that represents all of the digits. Now, if you look at this box plot, when you look at the left-hand edge, now this is called your box, and these are called your whiskers. So on the box and whisker plot, when you look at the whisker on the left-hand side, it goes all the way out to the number 1, so the lowest score would be a 1. We can see where Q1 and Q3 and the median and the highest score sit as well. So you've got the lowest score, the edge of the box is Q1. This line in the box, wherever it is the middle score. This is Q3, and this is the biggest score. Remember, numbers don't always spread out nicely, so sometimes they might be bunched up. This group, because this is not a very big whisker, the numbers are more bunched up towards the upper end, a little bit more spread out down this lower end. So the lowest score is 1. We can see Q1 is going to be 3. We can see the median is going to be 6. We can see Q3 will be 8, and the highest score will be 9. Well, sometimes you're going to get box and whisker plots or box plots that have a little cross out on the end. And now that's called an outlier. That means it's quite a long way away from your normal group of data. And we call it an outlier because it's just almost like a bit of a freak. Somebody's just done something that's just not normal compared to the rest of the group. Now there is a way mathematically that we can actually classify whether a number is an outlier or not. You use a special formula, and we'll teach that to you a bit later. But understand you can have outliers on the right. You could also have outliers on the left. So let's actually look at some data. The first thing you need to do when you get your data is make sure it's written in order from left to right, from smallest through to biggest. And we want to find the middle number, and you can see I've got 4 numbers, and my middle number is 25, so that's my median. When I go to the left, I've got to find the middle of that left group. 19 and 22 divided by 2 adds up to 20.5, so halfway between 19 and 22 is 20.5. If I go over to the right, halfway between 26 and 27.5, add them together, divide by 2, it's 26.75. So that's my value of Q1, and that's my value of Q2. So the lowest score is 17, Q1 is 20.5, the median's 25, Q3 is 26.75, and we can see that the biggest number on the end is 29. So that's my data, and I've got my 5-point summary now. Now we can do a box plot. First thing you need to do technically is you should be using a ruler. It's one of the few times you need to really use a ruler in advanced maths, and our spacing needs to be consistent. Now I can see the smallest number is 17, so that would be a 17, and I would then go all the way up to 29. So this particular one I've gone goes up to 30. That doesn't matter as long as you have 17 through to 29 included. Now I'm going to put a vertical line at 17. I'm going to put a vertical line at all of these positions. So a vertical line at 20.5, a vertical line at 25, a vertical line at 26.75, where I think it is, and one at 29. I then put my first whisker, create my box, and then my second whisker, and there is my box plot or my box and whisker diagram. Let's try our second example. Now this box plot summarizes the ages of people at a party. The first thing says find the maximum or minimum and the maximum age. Well, we can see the minimum age is going to be 15 at the party, and there is a 29-year-old at this party. So the minimum age is 15 and the maximum age is 29. Let's look at the range of people at the party. Remember, age is the biggest number minus the smallest number, so it's just 29 take away 15, which is 14. There's a 14-year age range between the oldest and the youngest person at this party. Now, what's the median age? Well, that's the middle age, and if we look here, the median age at the party is 22. What's the interquartile range? Remember, the interquartile range is Q3, which is there, minus Q1, which is there. It's the middle 50% of the data. So it's going to be 27 take away 17 if we look at our scales there. And 27 take 17 is 10, so the interquartile range is 10. There's a 10-year spread in the ages of the middle half of the age groups at the party. Now, 50% of people are below what age? Remember, the median represents the middle score. So half of the people will be younger than 22 and half of the people will be older than 22 at this party. Just like if I come here, a quarter of the people are younger than 17, 3/4 of the people are older than 17. If I come to this point here, 3/4 of the people are younger than 27 and 1/4 of the people are older than 27. That's the way we're using our box plot. So when we look at this question here, it said, what percentage of the people, 50% of the people are below what age? Well, 50% of the people, there's 25%, there's 25%, 50% of the people are below 22. 25% of the people are above what age? We can see this is the last quarter here. So 25% of the people are above 27. Now, if there were 200 people at the party, how many people would be aged below 17? Well, let's look at the 17 here. 17 occurs at the 1/4 way mark. So 1/4 of the people in the party should be aged younger than 17. If there are 200 people in the party, a quarter times the 200 people, or you could also say 25% of the 200 people is 50. So 50 people at the party are below 17. Well, time for you to try questions on these exercises. Enjoy. I know you will because you all love mathematics. Bye for now.